Hello, Paul here, and today what we are working on is this Sylvania radio. But it's a very nice radio. It's got a clock, uh, real nice color, and we're going to make it work. It is a model R5484 14902, and I assume that's a model number. That might be a serial number, but so I would think it would probably be the R5484, but I'm not sure. But we're going to take the back off of it and look at it, and I'll pull up a schematic at some point soon, and we'll go from there. It does power on. I have powered it on. I couldn't leave it on because, of course, it has a bad filter capacitor. So loud hum, a lot of DC leakage. You definitely don't want to leave a radio of this age plugged in and turned on for any length of time until you recap it. So let's pull the back off and see what we get here. I don't think this radio has been taken apart. The screw is very tight. Yeah, I don't think it's been taken apart. And this probably got the antenna on it, so we got to be careful. And it does. And it is a 1, 2, 3, 4, 5 tube, All-American 5 radio. And the knobs are on the side, which is really interesting. We'll go ahead and take them off so we can get it out of the chassis. Okay, that's one. This one's a little tight. There's a clip on it down there. I don't think that clip is really holding anything, but let's see if we can wiggle that off there. And there we go. It's always better to get something moving in a logical way so you don't break the plastic by trying to yank on it. If this has never been opened, this has been on here a long time. So I'm just turning it in that slot. I don't know if you can see that, and the width of the screwdriver is giving leverage to pull it. I think I got it. So that holds that on there. Okay, well, we'll leave that there. It does have a clock, so I don't know if the clock comes out with it. Probably not. I don't know, it might. Let's take the screws out of the bottom and see what we find. Yeah, it don't look like these screws have ever been out of there. So I'm assuming nobody's been in this guy. Let's see. Okay, we got clock has some knobs on it too, but let's see if that will come out without the clock. Now apparently no, the clock comes out with the unit. So we got to pull these knobs off as well. And again, if you pry them gently, turn them a little, pry them a little more, turn them a little, you can probably get them off without hurting them. Okay, I got that one started. I mean, I could probably just yank on them, they'd probably come right off, but it's good to get them started to know that there's no problem with them, that you're not going to bind something and bend something or break the knob. So you want to be gentle with them. Oh, that one pulls out to set the time. Some of these sometimes screw on and you don't want to yank on them if they screw on. No, this one just pulls off. Okay, now we should be able to get the chassis out. We didn't give you much wire on this antenna board. Okay, and there you have it. And I see a piece of a bumblebee capacitor there. So we know we got a problem with that. And here's a dead mullet. You know, some miscellaneous garbage in there. This is the lens, which has a small scratch in it, but I think I can buff that out. It's just a thin plastic. So we'll try to polish that up when we polish the case and get this case with the dead bugs out of here. We'll blow that out later. Clean it out. I'm just getting the worst of the junk out of the bottom, so I don't have a lot of junk in here. Okay. Now, let's see where this guy came from. And take a look at the bottom. And there we have it. And there's that bumblebee capacitor. It just totally blown apart. So it's a wonder it even did power up. But like I said, I didn't leave it on for long. I just powered it up enough to check that. Check the electronics in it. Some dust. I'll blow this out just a little bit here. Try and get some of the junk out. Dead piece of oak tree's gone. Okay. Some more garbage. Alright, so we got a broken bumblebee capacitor to deal with. Let's see if we can get this to sit underneath there where there won't be any damage to it. Good. And there we have it. So this filter capacitor is definitely shot, so we got to get rid of him. And what it is 240 microfarad capacitors at 150 volts. So we'll take a look at them and see what they're reading. That'd be interesting to see. We got a boiled up wax capacitor here, 2 more wax capacitors here, and I don't know if this guy will have to go. He looks pretty stable. He might be okay. It's a multi-lead. Looks like mica. Interesting. They have, like, looks like they have 3, maybe 4 capacitors in there. And we have a little transformer here. Most likely that's the speaker transformer. Yep. Yeah. Output transformer. Okay. Everything else looks okay. Interesting, they bent that pin on the inside there. That joker got a little bit warm. This wire melted right into the capacitor. And check the resistance on these power resistors. Look like 2.5 watt resistors here, 2 watt resistors rather. Not a very complicated circuit, very simple. Let me see what the tubes are. We haven't even checked that yet. Okay, we got a 12AT6, that's a 50C5, and this is a get my light source a little closer. That's a 12. Can't quite see in there. I don't know. We'll find out though. It's a 12BA6. Okay. Okay, and then there's probably another 35C5 here, I would imagine. 35W4, that's the rectifier. Okay. And this is a 12BE6. Alrighty, so those are the tubes. Turn it back up. Okay, I'm going to pause the video for a couple seconds, a couple minutes, and see if I can locate the schematic diagram on this. Alright, give me a minute or two to see if I can pull this up, and we'll be right back and continue. Okay, this is Paul, and I'm continuing this video on this Sylvania All-American 5 radio. I did find the schematic. It's a Sylvania 5484, which is the same as a 484. It's the same chassis. And the Bumblebee capacitor I'm just going to replace when I replace these. This one I was able to read it, but I found it on a schematic anyway. It's a 0.022. No, I might have to order that one. I don't have a 0.022. I do have some 0.0 .01s. I don't know if you can see that. And I can put 2 of those in parallel, which would give me .02, which is good enough because plus or minus 20%, I'm going to be well within tolerance if I do that. I don't like to use 2 capacitors, but in this case, it really is not a big deal. This is just a filter across the output transformer, and you know, any capacitor I place in, if it goes bad, it goes bad, right? So if I got 2 together, yeah, there's twice the chance that one of them could go bad, but that should not happen for a very long time, and then they can always put one back in. But I might order it. And I'm going to change these, the 2 filter capacitor here, that's 240s at 150 volts. They're no big deal. I've got some 47s, which are within tolerance. This is plus or minus 20%, so it could be anywhere from 32 to 48. So, and these, I'll make sure that I check my 47s and that they're on the lower end of 47. But, you know, that's a filter capacitor. That's just to get the ripple off the AC after the rectifier of 35W4. So it isn't really a big issue. But, you know, it'll be fine. The rest of them I have the exact values, and so we'll be fine on those. I'm sure these here are 2 to 3 times the normal value. So when we take them out, we'll measure them and see what they are. But I'm sure, like I said, I'm sure they're way out. So that's the next step. And we'll start working on that. And then I'll decide whether I want to order that one or use these 2 in parallel. You know, capacitors in parallel are just the opposite of resistors in parallel. Resistors in parallel, if you put 2 100 ohm resistors in parallel, you're going to get half the value. It's the sum of the square, the inverse of the square root of the sum of the squares. So basically it's half of 2 equal resistors. With capacitors, it's different, because when you put capacitors in parallel, what you're doing is increasing the plate size spacing between the capacitors. You're doubling the plates. So it's like making the foil inside one of them twice as long. So instead of ending up with half of 2 equal values, you end up with twice 2 equal values. And so that's what we're going to do there. Let me go ahead and do that. We'll get the filter capacitors in. I'll replace these 3 for sure. I might leave that one in while I do a test. It isn't going to hurt anything. It's old, but that's all. It doesn't. I'm sure they're out, and they've been out for a long time, and this radio was still working before the filter capacitor finally kicked the bucket and started creating a loud hum. But we'll go with that. This guy here is some kind of, well, they call it a circuit board on the schematic. It has capacitors in it and also has resistors in it. We're just going to check the voltages after we do the capacitors, and if the voltages are okay, then I'm not going to mess with that, because I don't know if I could even find one. And if I did, it'd be a new old stock, and I'd be right back to where I'm at. So I'm not going to worry about that unless we absolutely have to. It appears to be mica, so it should be fine. Anyway, we'll work on changing out these capacitors and see what we get. And I'll continue the video after the capacitors are switched out. I'm sure you've seen people solder capacitors before, so not going to bother recording that. Anyway, we'll continue soon. Thanks for watching the video. Okay, I've got the capacitors installed in this Sylvania and about to turn it up and see what we can do with it. Bring my variac up here to about 117 volts. I'm going to stop around 70 here. That's 75 volts. And make sure everything's okay with the tubes. Okay, get a little bit of sound. Clock's running, don't smell anything. I'm going to kick it up some more. Now this should start conducting 95 volts, so we should be able to play music. There we go. I have a lot of fluorescent lights in here, so it's going to be a lot of crazy.
We'll see if he can back up the leaderboard. He'll restart back in 7. Again, here is the top 10 coming to the green flag. Chase Elliott and Alex Coleman side by side, row 1.
A little bit of distortion there, but again, I have a lot of fluorescent lights in here.
Where are the Chevron?
Need to switch them to LED someday.
And they're led by Chase. Right, and do it yourself.
I'm actually getting a signal down here in my basement where my bench is, because I don't have much signals out here in woods anyway. That one's a little loud. Now that's fitting since I'm in Northeast Georgia. I haven't cleaned the controls, so there's static in the controls. I still haven't changed those two that capacitor that I didn't have in stock. Let me bring the voltage up to current voltage. Okay, you can see it there coming up. I guess you can see it on my meter there. So we'll bring it up to about 100, somewhere around 120. A little more than the radio is designed for. Actually, it's rated for 117, so we'll back it down. And at 117 volts, we're drawing 250 milliamp, and that's 28 watts, which is about right. I imagine this radio is rated at 30 watts or so. 250 milliamps is not bad. So the current's fine. Bring the voltage all the way up to 120. Okay, now we're operating about my mains voltage. Let's try some other stations before YouTube gets upset with me. You know, I always say, do not record any of the music you hear off these antique radios that I do that's got all this kind of static and noise. Because, you know, it is copyrighted music, and they wouldn't want you to record this staticky sounding music and then try to sell it or something and, you know, cheat them out of their income, out of their money for their copyright. So, you know, I don't understand it, but we live in a crazy world. To me, if I'm tuning in the station on the airways, it should be free. It always was. It's one of my pet peeves. It's coming in on the airways. Nobody should have any copyright information on it, but again, I don't have a lot of stations here. That one really comes in. And I haven't tuned the IF cans, I haven't checked the tubes, I haven't done nothing with this radio yet. So after switching out the capacitors only, and that ain't even all the capacitors, I still have that one to do. I'll probably go ahead and just use these two together because the radio is in great shape. These are brand new capacitors. They're overrated voltage wise, so you know they can handle whatever voltage this radio is gonna put out. I think they're rated at 600 volts. And these, yeah, 600 volts, actually probably 630. World's smallest print, 630 volts. So, you know, there's not going to be any problem with them. They're in good shape. The radio is in good shape. Tubes are in good shape. Chassis is really clean. I haven't cleaned this. You see me blow a little dust out of the bottom, but look at that chassis. That's amazing. This radio is well taken care of. And so I'm going to continue doing a little fine tuning on it, clean up the case, polish it, and then put this radio out on the market. And I think it's a really good radio for make someone a good collection piece. Anyway, thank you for watching my video. I'll finalize this with a link to a video in the description, or continue this video, I don't know which, with the finished product in the case and playing. But thank you for watching the video.